Hi, welcome to the 5th in the FARO Laser Scan to BIM video series. In part 2 of this guide, we are going to continue looking at workflows for creating site topography from FARO scan data. Okay, so the first thing I'm going to do is I'm going to go to my Tools menu and scroll down to Apps. And I'm going to activate the Surveyor app. This is going to give me a new icon at the top, which I can select and load in a new toolbar with a variety of features. So next I'm going to zoom in on an area of interest, such as this curb here, and I'm going to just go to our layer manager first, which is similar to CAD, which allows us to define new layers, and there are some preset layers already available. However, we will add a new layer in called curb. Click OK, and we'll select that as the active layer. I'm then going to go and change the colour of my line work. So I'm going to add a new colour in here. Let's go with this red and click OK. So if we just have a look at the menu along the top, there's a variety of options here. But the first thing we're going to do is draw a line. So if you open this menu, we can do a straight line, a polyline, a circle. But first of all, we're going to draw a straight line from point to point. So if I just zoom in to get a little bit of a better angle here. So if we just pick the first point and then the second point on the curb, it's then going to prompt us to add a label. So we add curb and click OK, and you can see that line is now drawn with a length, and it's also hovering slightly above the location of the curb. Okay, so now I'm just going to deselect the line itself, and if I open up this menu here, we have the ability to change the level above the points that this is shown. Now this is just a graphical representation to aid with drawing line work really. So we can make this as high or low as we want, but the actual point itself, the actual line itself is selected on the point. So if we next go and zoom back in here and select a polyline, and we pick a few points on this angled curve here, we can see the Z is a little more dynamic as we're able to select multiple points. So when I've finished this, I'm then just going to press the space bar, and it's going to prompt me to label the line, but also decide whether I want to close this or end the line. So I'm just going to select end and OK, and again the line is closed and labelled. So let's just move on here and look at how we can use a similar command to generate line work on a rounded curve quite accurately. So if we just zoom in on this rounded curve here, you can see if we go back to the list, we have the option to select the rounded curve, and if I just select 3 points, so start, middle and end, and press a return key, I can go back and add a label in again. So if I just add curve again, click OK, it's generating that curved line work for me there and giving me a dimension. So the next feature we have here is the field to finished point command, which enables us to create a number of points on the site with Z values. So if I just type in manhole here and start this at number 1, I could then zoom in on this manhole and double click and create a fixed point. Now if we just have a quick look at this, it's given us a fixed point, it's given us the label, and then it's also given us a Z value for that specific point that's been selected. If I want to, I could go in now and change the layer and create a new series of points. So if we go in and select road, obviously this is going to be green. Click field to finish point again, and we're going to label this one road, and we're going to start this again at number 1. Click OK, and we can now go in and select some new points around the site and create a series of points which we can bring through into AutoCAD later on. In the last video, we did also have the option to create a series of points exported on a grid, which is on a defined grid. So here we had 0.5 meter spacing on our point. However, the next tool I'm going to show you is the ability to determine a slope. So if I select the determine a slope command and pick my first and second point and add a label to this, so we'll call this road slope, and click OK. This is going to give me a arrow pointing in the direction of the slope, and it's going to give me the slope in a gradient format. We can actually go into our settings now, and we can change the way this is displayed. So if I change this to degrees and click OK, you can see that's actually updated there. We also have the ability to add in some basic text. So if I select this ABC command and double click a point, perhaps on this fence, we can add a label. So we type in fence and click OK here. And the next feature we'll look at is creating topographic contours. If I select this, or if I first go into my settings, just to show you that we have some predefined profiles which we can use, or we can create new ones which define the spacing on the contours and how it actually creates those contour maps. But if we simply select the contour from the menu here and select 4 points, for example, and we will just click return, you can see that algorithm's ran now and that has generated a contour map. So if I turn off my point cloud just for ease of visibility and spin this around a little bit, we can zoom in now and we can see the different colours and different contour spaces that have been used to define this contour map of this small area. Okay, we'll just zoom out of that. I'll turn the point cloud back on. Okay, so the next tool I'll show you will be the coloured cut and fill map, which will not create CAD data but will just literally colour the points. So we select this tool up here and we select 4 corners, press return, and as you can see we now have a colourised area of points with level information. Okay, so the next thing we're going to do is generate a tin mesh based on a defined area of points. So if we select the tin command from the menu, we can just quickly pick 4 or 5 points and press the return key to close off the area. We then select the reference elevation, which in this case will be the road itself, and give this a few seconds and it should generate a triangular irregular network mesh, which we can then export to Civil 3D or similar, or AutoCAD as an XML file if we want to, or we can take this out as part of a DXF package which we export from the Surveyor app itself, so bring out all of the information as one. You can just see that there. If we zoom in, you can see some of the triangular mesh details that have been created. So we now have the option to either save the workspace that we're working in to be opened up at a later date and completed or added to. And we can do that by clicking the disk here and saving the file out as an XML, as the Surveyor tool format, which we can open up again. However, we can also export all of this information in a variety of formats, so land XML. But in this instance, I'm going to open this up in AutoCAD, so I'm going to use the DXF command. I'm going to browse to a location and just save this out as Surveyor App Test, DXF test. And we'll just press save and export. This will just take a couple of seconds, export success, and then what we will be able to do is open this up in AutoCAD and align it with the point cloud and potentially then add in any more information we want before we bring this into Revit. Just going to go back in now, turn off my point cloud, and you can see the information that should have been exported. Okay, so I've just opened up AutoCAD 2015 here, and the first thing I'm going to do is just go and find the DXF export that we just created in the Surveyor app and open that up. If I just zoom extents, you can see this information. If I just rotate around and select some of these lines, you can see that this has brought the layer information through with it. So if I just select this one, there we are. So we've got road, we've got road and curb, which were the 2 layers we created. Now this also should be aligned to the same coordinate system as the point cloud we used. So if we now go to insert, attach, and go and find the point cloud, export from scene, and we open that up, and now what we're going to do is we're going to insert that with the insertion point at the zeros XYZ 000, so that the coordinates match the DXF and the point cloud. So I'll click OK here. So that should just load in. There we are. There we are. Just rotate around. There we are. So you can see the line work that we created in the Surveyor tool has come through in the correct place and lines up with the point cloud. So, I mean, in this instance now, we have a couple of options. What we could do is we could augment this with some additional information in AutoCAD, which we can then bring into Revit as a DWG file potentially, and give us a kind of outline to divide up our CSV file surface that we've created, our topographic surface we created in Revit from the CSV file export, as shown in the previous webinar. Or we can just literally use this as 2D information. So if I just quickly show you the snap settings that are available in CAD, so if I just open up snap settings, we do have this tool here called 3D Object Snap, which it's quite important to have turned on when you're doing any 3D information. And this gives us the ability to snap to planes, nodes and perpendicular points in relation to 3D information, or 3D point clouds as it were. So if I click OK here, and if I just zoom down onto a place where we have some point cloud information that drops in the Z value, so potentially this drop curve here, there we are. So if I just now type in 3D poly, what we're going to do now is pick the particular points and create a 3D polyline, which, as you can see, snapping to the individual points, and every new point that I create defines a new Z value. So this is actually a 3D polyline, as it were. Just to show you that that's actually correct, if I just select this line here and turn off the point cloud, we can obviously see that that has some changes in the Z value during that little, shown on that little drop curve. Now we could go around and create a full 3D topographical surface if we wanted to, using this technique. So we could pick that up there and continue it across here. However, it's quite likely that a lot of people won't want to create 3D line work, and it can be a little bit excessive for most applications. So in that case, what we would normally do is create a new UCS, or a unique coordinate system, to kind of orientate our scans around. And we can then use just 2D line work with a set Z value or set coordinate system, which is going to give us basically an outline plan of the area. So we're effectively using the point cloud as an orthographic image in that instance. So to do that, what I'm going to do is I'm just going to go down to this little menu here and select New UCS. So we've got New UCS there. And I'm just going to go down and select, for example, this curve here as my origin point. I'll then select my Z or my X reference roughly along the line of the curve, and then my my Y, is going to be just off the angle here. Sorry, I'll just do it this way. There we go. So now if I just rotate this all around, we have a nice squared up plan that we can use to create some 2D information with the defined Z value. So in this instance, I no longer need my 3D object snap turned on, so I'll go and turn that off. Okay. We're then going to go into our 2D line work commands, and we can start to annotate some of the information here just using the standard commands. So there we are. We can just start to draw this on here. For example, this manhole. Potentially some of this line work or this curve here. Now remember, if there's any changes in the Z value, they won't be picked up using this method. So we're literally just sketching in 2D, as it were. So just drop that down on an angle, and zoom in again. You can see that that line work is kind of hovering above the point cloud in this instance. Okay, I'm just going to pause the video now and I'll continue to draw some 2D line work which we will eventually bring into Revit to help us divide up the topographical surface. Okay, so I've spent a little bit of time there just putting some line work onto the top of this point cloud now. So if I just turn off the project point cloud, you'll see exactly what we have. So we've just used mostly 3D polylines to just fill in some of the detail on the road and pavements. So what I'm now going to do is I'm just going to save this out as a DWG. So that's going to bring through everything that we did in the Surveyor app and also everything that we've done in AutoCAD. So I would just go obviously File, Save As, and I've already saved this out here as Revit Topography as a DWG. I'll press Save. Okay, and we'll just go across to Revit now. So the idea of what I'm trying to achieve here now is to combine the CSV surface that we created in the first part of the video with the DWG information we've now created with the Surveyor app and AutoCAD. So if I go to my site level, and the first thing I'm going to do is just go and insert the AutoCAD drawing we've just created. Just going to find that now. And we're going to import this origin to origin, and we're also going to make sure that the units are set to meters. Click OK. There we go. So there's the line work that we created. As you can see, all of the Surveyor app information's come through as well. Next, we can go to our CSV file that we used in the first video, and we're going to bring that in to create the surface behind here. So I'm just going to go to my Massing and Site tab, Topo Surface, and then I'm going to go Create from Import and specify a points file. I'll then go and find the CSV file that we exported and click OK. The units need to be set to meters again, so OK. And I'll just click the green button there. And if we just drop into the 3D view, you should be able to see that that's nicely aligned with the CAD geometry we've created. I can also at this point just turn off the contour maps completely, just to make it a bit easier to select these lines in a minute. And I'm also going to bring in the point cloud that we've just used. And I'm going to bring that in origin to origin, just to show that everything's aligned once it's brought through into Revit. There we go. Okay, and I'm just going to use my Point Sense tab to hide that point cloud. Now, if we just navigate around here, the next step will be to divide this topo surface up using the line work as a kind of guide. So if we just drop down into a top-down view, and center this now, if I go to my Master and Site tab again, we have a tool here called Split Surface. So using the Split Surface tool, I can select the main area of the point cloud, and then what I can do is I can either use the pick line command, or I could use the draw line command, and we can divide this surface up into smaller sub areas, which we can then label with different materials. So if I show an example here using the pick line command, I'm just going to zoom in and use some of the road line work that we created. Just go around here slowly. One thing we do have to be careful of is that all our lines are closed in loops once we complete the line drawing. And also this area that's overlapping at the back here will need to be brought in to match the actual surface layer itself. just going to drag this area in a little bit. Close that a little off there. Okay, so now if we click the green tick, you can see this area is now completely selectable on its own. So we've created a sub area within that surface, or split the surface I should say. But what we can now do is go into the material specifications and we can find a bitumen surface, or asphalt surface. There we are. Click OK, and now you can see we're starting to build up different surfaces based on the line work that we've produced in the Surveyor app and the AutoCAD drawing. So what I'll do now is I'll just pause the video and I'll divide up all of these surfaces to give you an idea of how it should look at the end. Okay, so I've just taken a little bit of time there, and as you can see I've divided up the surface into some of the different areas that we have, such as the road, the pavements, some grassed areas and some earth areas. What I've also done is I've deleted out the original topographic surface that we created, just to avoid any overlap. If I wanted to now, I could go in and I could select this AutoCAD drawing and we could just hide this off. There we are, just to give you a better idea of what you're looking at. And if we wanted to, we could also go back and add some contours to this. So if we go into some contours again, there we are. So now we're just looking at contours of the areas that we want to see. What I've also done is, while I was doing this, I loaded in the original point cloud, which shows the surrounding buildings. So if I just go back to my point sense tab and unhide the point cloud, uncleaned, so it has all the traffic noise, the original traffic noise on, but it gives you an idea of what we were trying to create and how well it aligns. As you can see, some of the fence lines around here match up quite nicely with the pavements and the earthworks. So if you wanted to now, you could carry on and start modelling up some of the surrounding buildings, but you've got a nice topographic surface to work with. One thing you might notice if you have watched all of this video guide is that we did miss out creating a mesh from scan data within Civil 3D 2015 within these workflow guides. However, the reason for that, there's a very good video called AutoCAD Civil 3D 2015 Point Cloud Surface Extraction by a guy called Jack Strongathorn at Autodesk, and there's a link for it there. And that's a very detailed guide to some of the surface extraction features within Civil 3D. Okay, thank you everybody for watching, and I hope that was helpful for you.